Alright, today we are going to start reviewing for SC Ready. We're going to take this a topic at a time. So we're going to start by reviewing the number system. This is what we did at the very beginning of the school year. I'm not going to make you copy down the notes that you should already have in your notebook from the first 9 weeks. Unless you have lost that, then you do need to write this down again. Otherwise, I just want you to work the review problems with me. That does not mean that you get to flip ahead to the end of the video. You need to make sure you listen to every single word that I say and you work the examples with me as I work them on the board. Okay, so at the title, for the title of this lesson in your notebook, write the number system, and you can write number system review. And in this video specifically, we are going to be reviewing a couple of things: rational numbers. We're going to review adding and subtracting, and that'll be it for this one. So the standards that you have to know, we have to know how to represent the sum or difference on a number line and how to add and subtract rational numbers. We have to be able to multiply and divide all rational numbers, and then apply the concepts of all 4 operations with rational numbers: adding, subtracting, multiplying, and dividing, to solve real-world and mathematical problems. We have to be able to compare and order rational numbers, put them in order from least to greatest, use greater than, less than or equal to, greater than or equal to, and equal to. And then we have to be able to convert between fractions, decimals, and percentages. These are all the things they're going to expect you to be able to do on SC Ready. Okay. So first, let's review. You should already have this in your notes from the first 9 weeks, so just look at this table for me. Let's review the difference between a whole number, an integer, and a rational number. Whole numbers are the smallest kind of set of numbers, and whole numbers are like your counting numbers. It's going to be 0, and then every whole number that comes after that. 1, 2, 3, 4, 5, 6, 7, 8, and so on are our whole numbers. Integers, we still have the counting numbers and 0, but we also have the negative whole numbers now. So integers are either positive or the negative whole numbers. So 5 is an integer, negative 3 is an integer, 8 is an integer. Those are all integers, okay? And then a rational number is the biggest category. It includes all the whole numbers and all the integers, but then it's any number that you can write as a fraction. So all of these numbers, we can have fractions and decimals now. Those are considered rational numbers. Okay, so I want you to hit pause on this video, and I want you to make 3 columns in your notes: whole numbers, integers, and rational numbers. And I want you to see if you can place each of those numbers in the right category. Hit pause and do that real quick, and then hit play to check your answer. Alright, so check your answers with my answers up here. For the whole numbers, the only whole numbers we have are 13 and 0. If it is a whole number, that automatically is going to put these two into the integers category and in the rationals category. So I went ahead and wrote 13 and 0 also for integers and for rational numbers. Now when we get to the integers category, we see 13 and 0 that we had for whole numbers. Now we also add negative 7 and negative 125. Because those are the positive and the negative counting numbers, basically. Rational numbers is going to be everything else, your fractions and your decimals that we did not fit into the whole numbers and integers categories. Those are just rational numbers. Remember, the definition for a rational number is it has to be able to be written as a fraction. All right, next thing to review. Right here, one more question about that. If we have the number negative 39, what is the smallest category we can fit that in? Would it be a whole number, negative 39? No. Would it be an integer? Yes. Negative 39 would be an integer. What about 60? Is it a whole number? Yes. If it's a whole number, that automatically makes it an integer. Yes. A rational number. Yes. Okay, so hopefully you feel confident about the difference between fractions, whole numbers, integers, and rational numbers. All right, the second thing we're going to talk about today is adding and subtracting integers. This is going to be the last topic we're going to review in this lesson today, adding and subtracting integers. You should already have your steps for how to use the T-chart written in your notes from first 9 weeks. If you have lost that, copy this down again. If you still have it, then let's just do the review problems in your notes. You don't have to copy it down again, okay? How do I use the T-chart to add integers? Remember, if we put two numbers in the same column, we add. If we have them in different columns, we bring over the smaller number and subtract. Those are the steps to using the T-chart. So for this example down here, do this with me, draw a T-chart. 4 plus negative 2. 4 goes in the positive column, 2 goes in the negative column. We bring over the smaller number and we subtract, and we get 2. The sign of the column is the sign of the answer. So we get 2. That is the T-chart. Let's try some more practice. Hit pause. I want you to work each of these examples on your own. 1 through 5, do them in your notes. When you're ready to check your answers, hit play. All right, go ahead and check your answers to each of these, and I'm going to quickly work through each one if there was one that you missed. Let's just go over how to do it right now. Number 1, we would have negative 31 and negative 21. They're in the same column, so you add and get negative 52. For the second one, 8 plus negative 7. We bring over the smaller number and we subtract positive 1. For number 3, negative 5 plus 4. Bring over the smaller number and subtract negative 1. When we have the same thing, negative 18 plus 18, we're going to bring it over and subtract. That gives us 0. It's just 0. And then when we have 3 numbers, we're just going to work from left to right. So I'm going to start with the first 2 numbers, 11 plus negative 4. Bring over the smaller one and subtract. That's 7. Then I'm going to add in the negative 11. So that will be right here, 11. Bring over the smaller number and subtract. And that would be negative 4 for my answer. Questions about that, just ask me. Adding and subtracting using the T-chart. Okay, if you have subtracting integers, if you have a problem like this right there, remember the sign in front of the number tells you the sign of the number. So let's practice again using the T-chart to work these out. And remember that a double negative makes a positive. We talked about that a long time ago. When we have minus a negative, we say plus plus. So hit pause. I want you to work these 6 examples in your notes. When you're ready to check your answers, hit play. All right, number 1, negative 5 minus 8. Negative 5 minus 8. Okay, remember 5 is negative, 8 is also negative. So those go in the same column. We add them together and we get negative 13. Number 2, notice we have minus negative here, so I'm going to go plus, plus. Now it's 6 plus positive 5. Those just both go in the positive column. 6 plus positive 5 is positive 11. Negative 2 minus 8. Negative 2 is negative. 8 is negative. They go in the same column and I add, and I get negative 10. Okay. Number 4, negative 3 minus 9. Remember, 3 is negative, 9 is negative. So let's go in the same column, and I add negative 12. 17 minus 8. Bring it over and subtract. That's 9. And then plus, plus. So that's going to be erase. There. No. There. So 4 plus positive 12 is 16. Positive 16. All right, so that's how to use the T-chart for subtracting. It's the same process as using it for adding. You may have a question about a number line. So if we had this question, -5 plus -2, we would use the first number as our starting point, -5, so you put a dot on -5. And then if it tells you to add -2, am I going to go in the positive or the negative direction? I'm going to go in the negative direction because I'm adding -2 to it. So I'm going to go 1, 2, to the left. Where do I end up? -7. So I move to the left 2 units, and it gives me -7. So you may see a question. I saw some while y'all were working on map where it gives you a number line. So if you have to model this using a number line, that's what you would do. Okay. Last thing to talk about is additive inverses. If you do not still have your notes from first 9 weeks, you need to write this down. If you do, then you should be good. Let's just quickly review. When we say the term additive inverse, it's when you have two numbers that add together to give you 0. It's a number and its opposite. So think about a number and its opposite would be like 5 and -5, 3 and -3, -2 and 2. It's every number and its opposite. Those are called additive inverses, and when you add them together, they give you 0. Just like a couple problems ago when we had -18 plus 18, these were additive inverses. That's why it gave us 0. Okay, so look at these options. I want you to hit pause and find the ones that are additive inverses. Remember, it's a number and its opposite. We should be finding 5 and -5, 8 and -8, 12 and -12, -5 and 5, -8 and 8, and that's it. These are not opposites, these are not opposites, these are not opposites. Okay, what is the sum of every single one of those that I have circled? If I added them together, it would give me 0. On your own, which pairs of integers are additive inverses? Take a quick look. You should be getting B and C, a number and its opposite. These are not the same number. These are not opposites. So only B and C. Okay, absolute value. Remember absolute value, the symbol is straight up and down lines. And what it does, basically it makes a number positive. Okay, you're finding the distance from 0 on a number line. That's the definition of absolute value. So if I told you to find the absolute value of -8, it would be 8, because it's 8 spaces from 0 on the number line. If I told you to find the absolute value of 2, it would be 2. If I found the absolute value of -7, it would be 7. Absolute value of 5 would be 5. You see how the number stays the same, it just makes it positive. Always going to be positive. So it's not the opposite, it's making it positive. All right, at this point you should be ready to tackle the digits assignments that are assigned to you. These are going to be review assignments on rational numbers. You'll see one called rational numbers, and I think there's a separate one called adding and subtracting. Raise your hand if you need help.